Dear students, today we are going to discuss JEE Mains previous questions as well as latest February 2021 JEE Mains questions. The chapter is sets, relations and functions. Right. See this, let capital R is a relation defined by set of all ordered pairs P comma Q such that P and Q are at the same distance from the origin. Right, that is a relation. Then the equivalence class of 1 comma minus 1 is the set. Right, the equivalence class of 1 comma minus 1 is the circle passing through minus 1 and center at origin. Circle passing through 1 comma minus 1 and origin center at origin. Center that is equal to origin. Now radius is equal to square root of 1 square plus 1 square that is equal to root 2. This is the radius. Now this is the center that is origin and R is the radius that is root 2. Now the required equivalence class is a circle passing through 1 comma minus 1 and the center at origin, that implies x minus x1 whole square plus y minus y1 whole square is equal to r square. 1 is the center of a circle, so that implies x square plus y square is equal to r square root 2 whole square, that implies x square plus y square that is equal to 2. That is the required answer. So option 2 is the answer. Right. Now next question number 76. Right. This is, let capital A is a set containing 10 elements from 1 to 10 and F mapping from capital A to A be defined as f of k is equal to k plus 1 if k is odd, equal to k if k is even. Here f is a piecewise function. Then the number of possible functions G mapping from capital A to A such that G circle F is equal to F. Given that G circle F is equal to F, G circle F is equal to F, that implies G of f of x is equal to f of x, G of f of x is equal to f of x, that implies G of y is equal to y. That is the given condition, G of y is equal to y. Right. Now let f of 1 that is equal to, here 1 is odd, so that f of 1 is equal to 2, that is also equal to f of 2. Similarly, f of 3 that is equal to 4, that is also equal to f of 4. Next, f of 5 that is equal to, here 5 is odd, so that its image is 5 plus 1 that is equal to 6, that is also equal to f of 6. Now f of 7 that is equal to 7 plus 1 8, that is also equal to f of 8. Now f of 9 that is equal to 9 plus 1 10, that is equal to f of 10. right? So f of 1 equal to f of 2 is equal to 2. Similarly, f of 3 is equal to f of 4 is equal to 4, and f of 10 is equal to 10, right? Now applying g on both sides, that implies g of f of 1, g of f of 1, that is equal to g of f of 2, g of f of 2, that is equal to g of 2, right? From this, g of y is equal to y, so that g of 2 is equal to 2. G of 2 is equal to 2, right? Now g of f of 3, g of f of 3, that is equal to g of f of 4, that is equal to g of 4, that is equal to g of y is equal to y, g of 4, that is equal to, right? Now continuing like this, we get g of 6 is equal to 6, g of 6 equal to 6, g of 8 is equal to 8, and g of 10 is equal to 10. G of 10 is equal to 10, right? Okay, now the number of possible functions from g mapping from capital A to A, that is the elements of capital A, particularly 2, 4, 6, 8, 10. The images are, the image of 2 is 2, the image of 4 is 4, the image of 6 is 6, the image of 8 is 8, the image of 10 is 10. Now, what about the remaining elements? The remaining elements are 1, 3, 5, 7, 9. What are the images of 1, 3, 5, 7 and 9? The element 1 mapped to any one of 10 elements of set A. The number 1 in A is mapped to any one of 10 elements in set A. So the image of 1 in set A of 10 ways. Similarly, the image of 3 in 10 ways, the image of 5 in 10 ways, the image of 7 in 10 ways, the image of 9 in 10 ways. Therefore, the number of functions G mapping from A to A is equal to 10 power 5. Right? The option is option B. Right? Now, next question. Let f comma g mapping from capital N to N such that f of n plus 1 is equal to f of n plus f of 1 for all n belong to n. Right? Here f is defined like this, and g be any arbitrary function which of the following statements is not true. Okay, see the question carefully. Which of the following statements is not true? Right. So here f is defined like this: f of n plus 1, f of n plus 1, that is equal to f of n plus f of 1. Put n is equal to 1, put n is equal to 1, that implies f of 2, that is equal to f of 1 plus f of 1. F of 1 plus f of 1, that is equal to 2 into f of 1. Put n is equal to 2, n is equal to 2, that implies f of 3, that is equal to f of 2 plus f of 1. F of 2 is 2 times f of 1, 2 times f of 1 plus f of 1, that is equal to 3 times f of 1. Right? Continuing like this, f of n that is equal to f of n that is f of 1. Right? Clearly, distinct elements have distinct images. Clearly, distinct elements have distinct images, so that f is 1 1. So that f is 1 1. Right? If f is onto, if f is onto, if f is onto, f is onto means range is equal to codomain. F is onto range that is equal to codomain. Okay, that is possible only when, that is possible when f of 1 is equal to 1. F of 1 is equal to 1. That corresponds to f of n is equal to n. F of n is equal to n for all n belong to n. F of n is equal to n. Right? F is 1 1, that is true. If f is onto, then f of n is equal to n, that is also true. Now, if f circle g is 1 1, then g is 1 1. That is a known property. If f circle g is 1 1, then g is 1 1. Finally, this is not true. Okay, the statement A is not true. If G is onto, then F circle G is 1 1. Right? Right. Now, next one. Let capital X denote the total number of 1 1 functions from a set A with elements to a set B with 5 elements. Right? Number of elements in set A, that is equal to 3. N of B is equal to 5. N of A is equal to 3. N of B is equal to 5. X denote the total number of 1 1 functions. X denote number of 1 1 functions. The number of 1 1 functions is N of B, P n of A, N of B, P n of A, that is equal to 5p3. Now, y denote the total number of 1 1 functions from the set capital A to set capital B, then the from set A to set A cross B. Okay, y denotes number of 1 1 functions from set A to set A cross B. Set A to set A cross B. Right here contain 3 elements. Set A contain 3 elements. Set B contain 5 elements. Number of elements of A cross B. Number of elements of A cross B, that is equal to n of A into n of B. N of A into n of B, that is equal to 15. Right. So y denotes the number of 1 1 functions from set A to set A cross B. That is n of A cross B, n of A cross B, n of A cross B, P n of A. That is number of 1 1 functions. N of A cross B, that is 15. P, n of A is equal to 3 elements. Right. By seeing the options, what is x and y? Find the relation between x and y. For that, I consider x by y or y by x. For that, I consider y by x. That is equal to 15p3 divided by 5p3. 15p3 divided by 5p3. What is 15p3? That is equal to 15 into 14 into 13. 15 into 14 into 13. What is 5p3? 5 into 4 into 3. 5 into 4 into 3. Right? 15. 3 5s are 15 gets cancelled. This is 2 2s are 4. 2 7s are 14. That is equal to 91 divided by 2. That implies 2 into capital Y, that is equal to capital X. 2 into capital Y is equal to 91 into X. So that the answer is option C. Now let us see next one. A function f of x is given by, okay, right, f of x is equal to 5 power x divided by 5 power x plus 5. Then the sum of the series is equal to, right, observe the series. Okay, the first term, suppose the first term is x and the last term is, this is the first term of the series. Now last term, that is f of 2 minus x. The last term is f of 2 minus x. That is equal to f of 2 minus, that is equal to f of 39 by 20. F of 2 minus x, that is equal to 2 minus x means 1 by 20. 1 by 20, that is equal to 40 minus 1, f of 39 by 20. Right? This is the first term and this is the last term. Right? From the given function, establish a relation between f of x and f of 2 minus x. Right? From the given function, establish a relation between f of x and f of 2 minus x. Right? See, f of x plus f of 2 minus x. F of x minus x. F of x, that is equal to 5 power x divided by 5 power x plus 5 plus f of 2 minus x. That is 5 power 2 minus x divided by 5 power 2 minus x, 5 power 2 minus x plus 5, that is equal to 5 power x divided by 5 power x plus 5 plus 5 square divided by 5 power x divided by 5 square divided by 5 power x by taking LCM, that is 5 power x into 5. Right? That is equal to 5 power x divided by 5 power x plus 5 plus common in both numerator and denominator, 5 divided by 5 plus 5 power x. Now take LCM, that is equal to 1. F of x plus f of 2 minus x is equal to 1. Right? Okay, sum of first term and last term is equal to 1. Similarly, sum of second term from the beginning and second term from the end is also equal to 1. So here total number of terms are 39, so that its value is equal to 39 by 2. Its value, that is equal to 39 divided by 2. That is option A. Right? Now let us see another one. Set A containing 3-digit number, set B containing the numbers are of the form 9k plus 2 where k belong to n, and set C containing 9k plus L where k belong to n. n denotes natural number, and for some L lie between 0 to 9. Observe that L lie between 0 and 9. If the sum of all the elements of the set A intersection B union C is equal to 274 into 400, then L is equal to sum of all the elements of the set A intersection B union C, sum of all the elements of A intersection B union C. A intersection B union is equal to 274 into 400. Right? Sum of the elements of A intersection B union C, the elements is of the form sigma k is equal to 0 to 99, k is equal to 0 to 99, 99 plus 9k plus L, 99 plus 9k plus L plus 99 plus 99 plus 9k plus 2, that is equal to 274 into 400, 274 into 400, right? So once again, here given set A, that is a 3-digit number, 3-digit number start from 100, 999. B is a set containing 9k plus 2, k belong to n, C is equal to 9k plus L, where L lie between 0 and 9, right? Sum of the elements of A intersection B union C is of the form 99 plus 9k plus L. Suppose if we put k is equal to 0, k is equal to 0, 99 plus 900 plus L. L vary between 0 and 9. Here k is equal to 0, 99 plus 2, that is equal to 101. Right? Now simplifying this, sigma k is equal to 0 to 99, sigma k is equal to 0 to 99, 99 plus 198 plus 2, that is 200, 200, 9k plus 9k, 18k plus L, that is equal to 274 into 400. That implies, now applying sigma to each term of LHS, now 200 into 100, 200 into 100 plus 18k into 100, 18 into k is equal to 0 to 99. So 1 plus 2 plus 3 plus and so on 99, 18 into 99 into 100 by 2, 99 into 100 by 2 plus into 100 L, that is equal to 274 into 400. Okay, now cancel 100 on both sides. Cancel 100 on both sides. We get 200 plus here 2 nines are 18, 9 nines are 81, 9 nines are 81 plus 8, 891 plus 100 L, that is equal to 274 into 4. That implies 800 plus 200, 1091 plus 100 L. Here 100 cancel, simply this is L. That is equal to 4 4s are 16, 4 7s are 28 plus 1, 29, 4 2s are 8 plus 2 is 1096. That implies L is equal to 1096 minus 1091 that is equal to 5. Right? So this is a numerical type of answer. Here L is equal to 5. Right? This is very different question. Right? Now let us see next one. Let f mapping from R to R defined by f of x is a linear function, that is 2x minus 1, and g mapping from R minus 1 to R defined by g of x is like this. Then the composition function f of g of x is, right? First we find f of g of x. First we find f of g of x. Here g of x is equal to x minus 1 by 2 divided by x minus 1 by 2 by x minus 1. Right, now this is of the form f of x given f of x is equal to 2x minus 1, that is equal to 2 into x minus 1 by 2, 2 into x minus 1 by 2 by x minus 1 minus 1, that is equal to 2x minus 2 into 1 by 2 divided by x minus 1 minus 1, that is equal to 2x minus 1 minus x plus 1 divided by x minus 1, that is equal to x divided by x minus 1, that is of x. Right. Now verify this function is 1 1 onto and bijection. Right. For verifying 1 1, now consider its derivative. Suppose let it be y is equal to x divided by x minus 1. Now y minus 1, that is equal to x minus x plus 1 divided by x minus 1, that is equal to 1 by x minus 1. Now taking its derivative, dy by dx is equal to dy by dx, that is equal to, this is of the form 1 by x, its derivative is minus 1 by x whole square minus 1 by x minus 1 whole square and 0 for all x belong to r minus 1. For all x belong to r minus 1. Right? So this is f of g of x, and its derivative is less than 0, so that it is a decreasing function. It is a decreasing function of entire domain, so that the function f of g of x is 1 1. It is 1 1. Okay, now verifying onto. Right, let it be. Here y is equal to x by x minus 1. From this, that implies x minus 1 is equal to, x minus 1 into y, that is equal to x. That x into y minus y, that is equal to x. That implies x into y minus 1 is equal to y. That implies x is equal to y divided by y minus 1. X is equal to y divided by y minus 1. Right. Now, therefore, the range of this one is range of f. For finding range of f, let it be is equal to y. Simplifying this, we get the value of x. From this, the range of f circle G is equal to range of f circle G is equal to r minus 1. The range of f circle G is r minus 1. But the range is the codomain of F circle G, that is equal to R. Range is not equal to codomain. Therefore, the function F circle G is 1 1 but not onto. This is 1 1 but not onto. Right. Now let us see next one. Numerical type question. Given a plus alpha is equal to 1, b plus beta is equal to 2, and a into f of x plus a into f of 1 by x is equal to bx. Here this is a into f of x, this is alpha into f of 1 by x is equal to b into x plus beta by x, where x. Then the value of the expression f of x plus f of 1 by x divided by x plus 1 by x is. Right, observing the question, the required value is f of x plus f of 1 by x by x plus 1 by x. By eliminating a, alpha, b and beta from the given equations, we get the required value. Right, how to eliminate the constants a, b, alpha and beta. Right, given expression is a into f of x, a into f of x plus alpha into f of 1 by x, alpha into f of 1 by x, that is equal to b into x plus beta by x plus beta by x. Right, now replace x by 1 by x. Now replace x by 1 by x, replace x by 1 by x, that implies a into f of 1 by x plus alpha into f of x is equal to b by x plus beta into x. Right, now adding these two expressions, we get now a plus alpha into f of x, a plus alpha into f of x, a plus alpha into f of 1 by x, a plus alpha into f of 1 by x is equal to b into x plus 1, b into x plus 1 by x plus beta into 1 by x plus x, beta into 1 by x plus x. Right, now this can be written as a plus alpha into f of x plus f of 1 by x, a plus alpha into f of x plus f of 1 by x, that is equal to b plus beta into x plus 1 by x, b plus beta into x plus 1 by x. Right, here given that a plus alpha is equal to 1 and b plus beta is equal to 2. A plus alpha is equal to 1 and b plus beta is equal to 2. That implies f of 1 by x is equal to 2 times x plus 1 by x. That implies f of x plus f of 1 by x divided by x plus 1 by x is equal to 2. Right, therefore the value of the expression, that is 2. Now let us see next one. Right, suppose that a function f mapping from R to R satisfies the condition f of x plus y is equal to f of x into f of y. Okay, the function satisfying this condition is of the form f of x is equal to a power x f of x is equal to a power x, where a greater than 0 to 1, right? And f of 1 is equal to 3. Given that f of 1 is equal to 3, that means that a power 1 is equal to 3, that implies a is equal to 3, that implies f of x is equal to 3 power x, right? If sigma is equal to 1 to n, f of I is equal to 363, then n is equal to, right? Sigma I is equal to 1 to n, f of I, that implies expanding the sigma notation, f of 1 plus f of 2 and so on, f of n, that is equal to 363. What is f of 1? That is 3. What is f of 2? 3 square and so on, f of n, that is equal to 363. Now take 3 as common, 1 plus 3 plus 3 square plus and so on, 3 power n minus 1, that is equal to 363. Here the number of terms are in the sum is n terms. These terms are in GP. These terms are in GP. So the formula for the finite number of terms in a GP is a into r power n, a into r power n minus 1 by r minus 1, that is equal to 363. That implies 3 power n minus 1, that is equal to, here 3 1s are 3, 3 2s, 3 1s into 2, that implies minus 1 is equal to 2 1s, 2 2s, 3 power n is equal to 243, right? 3 power 4 is equal to 81, 3 power 5 is equal to 243, that implies n is equal to 5, that implies n is equal to 5, right? Here n is equal to 5, right? Now next one, right? For a suitably chosen real constant a, right? This is a real constant a. Let a function f be defined by f of x equal to a minus x by a plus x. Now also given f circle f of x is equal to x, f circle f of x, then f of minus 1 by 2 is equal to, right? So for finding f of minus 1 by 2, first we find the value of a. For finding f of minus 1 by 2, first we find the value of a by using this condition, f circle f of x is equal to x. F circle f of x is equal to x. F circle f of x is equal to x. That implies f of, what is f of x? A minus x divided by a plus x is equal to x. Again, this is of the form f of x, that implies a minus by a plus x divided by a plus a minus x divided by a plus x is equal to x. Now simplifying this, that implies a square plus a into x minus a plus x divided by a square plus ax plus a minus x, that is equal to x. Right, now cross multiplying this, a square plus ax minus a plus x is equal to a square into x plus ax square plus ax minus x square. Right, that implies take here x square a minus 1 into x square a minus 1 into x square. Now take x as common. Here ax gets cancelled. Here take x as common, a square minus 1, x as common, a square minus 1. Now this is a square minus a plus a minus a square, a into 1 minus a is equal to 0. Now this is true for all x belong to R. This is true for all x belong to R, so that a minus 1 is equal to 0. That implies a is equal to 1. Right, a is equal to 1. Therefore f of is equal to 1 minus x by 1 minus x by 1 plus x. Now we have to find f of minus 1 by 2, f of minus 1 by 2, that is equal to 1 plus 1 by 2 divided by 1 minus 1 by 2, that is equal to 3 by 2 divided by 1 by 2, that is equal to 3. Right, f of minus 1 by 2 is equal to 3. Right, now let us see next one. Set A has m elements and set B has n elements. N of A is equal to m, n of A is equal to m, and n of B, n of A is equal to m, n of B is equal to n. If the total number of subsets of A, okay, number of subsets of A is 2 power m, number of subsets of A is 2 power m is equal to 112 more than the total number of subsets of B, that is equal to 2 power n. Then the value of m into n is, that implies 2 power m minus 2 power n, that is equal to 112. Right, by verifying the values of m and n, m is equal to 7, n is equal to 4. M is equal to 7, 2 power 7, that n is equal to 4, 2 power 4 is equal to 16, that is equal to 112. Right, here we have to find m into n, that is equal to 7 into 4, that is equal to 28. Okay, right, now let us see next one. If f of x plus y is equal to f of x into f of y, and sigma x is equal to 1 to infinity, f of x is equal to 2, x comma y belong to capital N. Right, here f of x plus y is equal to f of x into f of y. Okay, here f of x plus y is equal to f of x into f of y. Then f of x is of the form a power x. F of x is of the form a power x, where a greater than 0 and a not equal to 1. Right, here sigma x is equal to 1 to infinity, f of x is equal to 2. Also given sigma x is equal to 1 to infinity, f of x, that is equal to 2. That implies f of 1 plus f of 2 plus and so on to infinity, that is equal to 2. What is f of 1? Here f of 1 is a, f of 2 is a square, f of 3 is a cube, and so on to infinity, that is equal to 2. Now, these terms are in geometric progression. Now, applying a by 1 minus r, a divided by 1 minus a, that is equal to 2. That implies a is equal to 2 minus 2a, that implies a is equal to 2 by 3. Right? A is equal to 2 by 3. So that f of x is equal to 2 by 3 whole power x. Therefore, f of x is equal to 2 by 3 whole power x. 2 by 3 whole power x. Now, we have to find f of 4 divided by f of 2. Now, we have to find f of 4 by f of 2. That is equal to 2 by 3 whole power 4 divided by 2 by 3 whole square. Right, 2 by 3 whole square, 2 by 3 whole square gets cancelled. That is equal to 2 by 3 whole square, that is equal to 4 by 9. That is equal to 4 by 9. Right, the option is option D. Now, let us see next one. Right, this is a numerical type question. This is a very logical question. Set A containing 3 elements A, B, C, and set B containing 4 elements 1, 2, 3, 4. Then the number of elements in the set is defined like this. F mapping from A to B is a function. 2 belong to f of A and f is not 1, 1. Right? Here range contains 2, but f is not 1, 1. Now, the possibilities of range are singleton set 2, set containing 2 comma 1, set containing 2 comma 3, set containing 2 comma 4, set containing 2 comma 4. Right? So, the number of functions and not 1, 1. Okay, set A containing A, B, C, set A containing 3 elements A, B, C, set B containing 4 elements 1, 2, 3, 4. Right? So, here this is the function is like this. Okay, 2 belong to f of A and f is not 1, 1. So this is only one function. Now let us see another possibilities of 2 belong to f of A and f is not 1, 1. Okay, now divide the elements of set A into 2 groups. One group containing 2 elements and another group containing 1 elements. Okay, set A divide 2 groups, one group containing 2 elements, another group containing 1 element. The number of ways of dividing 3 elements into 2 groups, one group containing 2 elements, another group containing 1 element is 3 factorial divided by 2 factorial into 1 factorial. Right. Now, let us choose 1, 3, 4 out of 3 elements. Let us choose 1 element out of 3 elements 1, 3, 4 in 3C1 ways. 3C1 ways. Okay. Now divide the elements of capital A into 2 groups. Suppose the group is like this. The elements A comma B, another group is the element C. These 2 elements mapped to 2. This element C is mapped to any one of 1, 3, 4 is like this. Okay, this is one way. Now another way is the image of A comma B is 1. The image of C is 2 like this. So this can be done in 2 factorial ways. That is equal to 3 factorial is 6 by 2. That is equal to 3. 3 into 3 into 2. That is equal to 18. Right? Therefore, the number of elements in the set C is the number of elements in the set C. Number of elements in the set C is, this is case 1, this is case 1, this is case 2. 1 plus 18, 1 plus 18, that is equal to 19. Right? So the answer is 19. Now let us see another one. Right? If the minimum and maximum values of the function f defined on domain, here mentioned that the domain is here, the domain of f is closed interval pi by 4 comma pi by 2. Now our aim is to find the minimum and maximum values of f over the domain pi by 4 comma pi by 2. Keep this in mind, the domain, right? First find f of theta. For simplifying f of theta by applying properties of determinants, R2 is replaced by R2 plus R1. R2 is replaced by R2 plus R1. Now f of theta is equal to determinant in first row minus sine square theta minus 1 minus sine square theta minus 1 minus sine square theta 1. Now replace R2 by R2 plus R1 minus cos square theta minus sine square theta, that is minus 1 minus cos square theta minus sine square theta, that is minus 1 minus 1 minus cos square theta minus 1 minus sine square theta, that is minus 3, that is minus 3. Now 1 plus 1 is 2. This is 12, 10 and minus 2. 12, 10 and minus 2. Now expanding this determinant, that is equal to minus sine square theta into 3 2s are 6 minus 20 plus 1 plus sine square theta into 1 plus sine square theta into 2 minus 24 plus 1 into minus 10 plus 36, the right, that is equal to, here 6 minus 20 minus 14 sine square theta. Now 2 minus 24 minus 22 minus 22 sine square theta, 36 minus 10, that is 16. That is 16. Right. Now here 16 minus 22, that is equal to minus 6. 14 sine square theta minus 22 sine square theta minus 8 sine square theta minus 8 sine square theta. Right, here theta belongs to, okay, now minus 6 minus 8 sine square theta, once see the calculation, minus sine square theta minus 1 minus sine square theta, this is 1. R2 is replaced by R2 plus R1, this is minus 1 minus 1 minus 1 minus 2 minus 1 minus 3, this is 2 12, 10, minus 2. Now expanding the determinant along first row, minus sine square theta into, right, minus 3 into minus 2, 6 minus 20. Now plus 1 plus sine square theta into minus 1 minus 2, that is 2 minus 24, plus 1 into minus 1 into 10 minus 10 plus 36. Now this is 6 minus 20 minus 14, 14 sine square theta. This is 2 minus 24 minus 22 minus 22 minus 22 sine square theta. 36 minus 10, right, this is 26. 26 minus 22, that is plus 4, that is plus 4. This is 4 minus 8 sine square theta. Take 4 as common. 1 minus 2 sine square theta. 1 minus 2 sine square theta, that is cos 2 theta. Right. Actually, the range of this function is cos 2 theta, the minimum value is minus 1 and maximum value is 1. Okay, this belong to closed interval minus 4 comma 4. But given that here the domain is mentioned, now finding the extreme values of this value within the domain pi by 4 comma pi by 2. Right, if theta belong to pi by 4 comma pi by 2, theta belong to pi by 4 comma pi by 2. Now 2 theta belong to pi by 2 comma pi. 2 theta belongs to pi by 2 comma pi. Cos 2 theta belong to, since cos function is a decreasing function, cos function is a decreasing function, cos 2 theta belong to cos pi minus 1, cos pi by 2, that is 0. Now multiplying with 4, 4 into cos 2 theta belong to closed interval, belong to closed interval minus 4 comma 0, closed interval minus 4 comma 0. Right. So this is the answer is option B. Right. Now let us see next one. A survey shows that 73% of the persons working in an office like coffee. Okay, this is a question related to sets. This is 73% of people in an office like coffee, whereas 65% like tea. 65% like tea. This is 60% of the people like tea. If capital X denotes the percentage of them who like both coffee and tea. Okay, this is X denotes the percentage who like both coffee and tea. Then X cannot be. Then X cannot be. Okay, right. N of A union B. Suppose this is A and this is B. N of A union B is always less than or equal to 100. That implies N of A union B, that is 73 plus 65, 73 plus 65 minus X less than or equal to 100. That implies 73 plus 65, that is 138. 138 minus X less than or equal to 100. That implies 38 less than or equal to X. 38 less than or equal to X. This is one inequality. Also, this is X. Now this is 73 minus X, and this is 65 minus X. From this, 73 minus X always greater than or equal to 0, and 65 minus x is always greater than or equal to 0. That implies x less than or equal to 73, x less than or equal to 73, and x less than or equal to 65. Now, the intersection of these two inequalities is x less than or equal to 65, x less than or equal to 65. From 1 and 2, this is 1 and this is 2. From 1 and 2, 38 less than or equal to x less than or equal to 65. Right? X lie between 38 and 65. Here 36 is not lies on the given range. X lie between 38 and 65. So 36 does not lie in this interval. Right? Now let us see another one. Here union I is equal to 1 to 50, capital Xi, that is a union of 50 sets. Now this is a union of n sets, that is equal to T, where each Xi contain 10 elements, each set Xi contain 10 elements, each Xi contain 10 elements, each Yi contain 5 elements, each Yi contain 5 elements. If each element of the set T is an element of exactly 20 of sets, right? Each element of the set T is an element of exactly 20 of sets Xi's and exactly 6 of sets Yi's, then n is equal to, right? See how to use this data, how to use the given data, right? So given that union I is equal to 1 to 50 Xi, 1 to 50 Xi is equal to union I is equal to 1 to n Yi. Okay, now number of elements of this union Xi is equal to number of elements of this union Yi. Okay, that implies number of elements in this is each set contain 10 elements, totally 50 sets, 50 into 10, 500. Now this is each Yi contain 5 elements, n into 5, but each element of T exactly 20 of sets Xi's. Each element of T contain 20 sets of Xi's, so this divided by 20, and each Yi exactly 6 of sets Yi's by 6. From this, here 10 2's are 20, 2 25's. Okay, now that implies 5n, that is equal to 6 into 25, 150, that implies n is equal to 30. Right? Therefore, n is equal to 30. Now, let us see next one. Let R1 and R2 be two relation defined as follows. R1, set of all ordered pairs A comma B such that A square plus B square is a rational number. R2 is a relation defined like this. A square plus B square is an irrational number. Right? Now, by seeing the options, verifying R1 and R2 satisfying transitive property or not. Right? Now, what is the transitive property? Transitive property is A comma B belong to R, A comma B belong to R, and B comma C belong to R, B comma C belong to R. That implies A comma C belong to R. Okay, then the relation is transitive. Okay, A comma B belong to R and B comma C belong to R, that implies A comma C belong to R, then the relation is said to be transitive. Now, verifying R1 is transitive or not. For the relation R1, for R1, right, A square plus B square belongs to Q. For that, I select one example. I choose one example. Let A is equal to 1 plus root 2, B is equal to 1 minus root 2, B is equal to 1 minus root 2, C is equal to 4th root of 8. Right. From this, now A square plus B square, that is equal to A square plus B square, that is equal to 2 into A square plus B square, that is equal to 6, belong to Q. That implies A comma B belong to R1. A comma B belong to R1. Now consider B square plus C square. What is B square here? B square 1 minus root 2 whole square. 1 minus root 2 whole square is A square plus B square minus 2AB is 3 minus 2 root 2. Now what is C square? Root 8, that is 2 root 2, that is equal to 3, belong to Q. That implies B comma C belong to R2. Okay, now our aim is to show that A comma C or verify A comma C belong to R1 or not. Now our aim is A comma C belong to R1 or not. A comma C. For that, consider A square plus C square. A square plus C square. What is A square? 1 plus root 2 whole square, that is 3 plus 2 root 2. What is C square? That is 2 root 2. That is equal to 3 plus 4 root 2. 3 plus 4 root 2, that does not belong to Q. Right, see this, here A comma B belong to R1 and B comma C belong to R1, but A comma C does not belong to R1. A comma C does not belong to, since A square plus C square does not belong to Q, that implies A comma C does not belong to R1. Therefore, the relation R1 is not transitive. The relation R1 is not transitive. Now, verify R2 is transitive or not. For R2, let A is equal to 1 plus root 2, B is equal to root 2, C is equal to 1 minus root 2. A is equal to 1 plus root 2, B is equal to root 2, C is equal to 1 minus root 2. Right, here what is R2? A square plus B square does not belong to Q. Right, now A square plus B square. A square plus B square. A square is 3 plus 2 root 2, B square, that is 2, 5 plus 2 root 2 does not belong to Q. That implies A comma B belong to R2. A comma B belong to R2. Now B square plus C square, B square plus C square, 2 plus 1 plus 2 minus 2 root 2, that is equal to 5 minus 2 root 2 does not belong to Q. B comma C belong to R2. Now we want to verify A comma C belong to R2 or not, or does not belong to R2. For that, consider A square plus C square. A square plus C square, that is 1 plus root 2 whole square, 1 plus root 2 whole square plus 1 minus root 2 whole square. That is equal to 2 times a square plus b square, 2 into 1 plus 2, that is equal to 6, belong to Q. That implies a comma c does not belong to R2. Right, a square plus c square does not belong to Q, then a comma c belong to R2, but here a square plus c square belongs to Q, so that a comma c does not belong to R2. Right, here a comma b belong to R2 and b comma c belong to R2, but a comma c does not belong to R2, so that R1 and R2, both R1 and R2 are not transitive. R1, neither R1 nor R2 is transitive. Right. Now let us see next one. Consider the two sets. Set A is equal to both the roots of given quadratic equation are real, and set B is equal to given set B, that is equal to closed interval minus 3 comma 5, right, 3 comma, sorry, this is open interval 5, this is open interval 5, right, this is open interval 5, closed interval minus 3 comma open interval 5. Now given a quadratic equation x square minus of m plus 1 into x minus of m plus 1 into x plus m plus 4 is equal to 0. Right, both the roots of this equation are real. It means that b square minus 4ac greater than or equal to 0, b square minus 4ac greater than or equal to 0. That implies m plus 1 whole square minus 4 into 1 into m plus 4 greater than or equal to 0. That implies m plus 1 whole square, m square plus 1 plus 2m minus 4m minus 16 greater than or equal to 0. That implies m square minus 2m minus 15 greater than or equal to 0. Now factorize this. That implies m plus 3 into m minus 5, m plus 3 into m minus 5 greater than or equal to 0. From this, m less than or equal to minus 3 or m greater than or equal to 5. m greater than or equal to 5. Therefore, set A is equal to minus infinity comma minus 3 union closed interval 5 comma infinity. Right, now these are the two sets A and B. Okay, by verifying the options, what is the first option? A intersection B. What is A intersection B? What is A intersection B? Also, see the question carefully. Which of the following is not true? Which of the following is not true? What is A intersection B? Right, minus infinity comma minus 3 and minus 3 comma 5. The intersection of A and B is minus 3. The intersection of these two sets is empty. Right. A intersection B is equal to singleton set minus 3. The statement A is a true statement. Now, what is statement B? That is B minus A. B minus A. It means that the set of all elements in B but not in A. The elements are present in B, not present in A. Right, this is minus 3 comma open interval 5. Here minus 3 is present in both B and A, so that b minus a is equal to open interval minus 3 comma open interval minus 3 comma open interval 5. Right, statement B is also true. Now, what is A union B? Statement C, A union B. What is A union B? A is equal to minus infinity comma minus 3. This is minus 3 comma 5 and 5 comma infinity. By observing those two sets, A union B is equal to capital R. Right. Statement A is true. Statement B is true. Statement C is true. Okay. Then the answer is fourth one. Okay. C. What is A minus B? What is D? What is A minus B? A minus B means the elements present in set A, not in set B. Right. Open interval minus infinity comma minus 3. Open interval minus infinity comma minus 3. And the elements closed interval 5 comma infinity. Closed interval 5 comma infinity. This is A minus B. This is A minus B. Therefore, D is not true. Therefore, the option D is not true. Right. Now, let us see next one. Right. F of x plus y is equal to f of x plus f of y. F of x plus y is equal to f of x plus f of y. F satisfying this condition. Also given f of 1 is equal to 2. Right. Here put x equal to y is equal to 1. Put x equal to y is equal to 1. That implies f of 2 that is equal to 2 into f of 1. F of 2 is equal to 2 into f of 1. Okay, and continuing like this, from this f of r is equal to r into f of 1. F of r is equal to r into f of 1. Right. Here given that g of n that is equal to sum of all the terms from k is equal to 1 to n minus 1 f of k that is equal to f of 1 plus f of 2 plus and so on f of n minus 1 and so on f of n minus 1. Right, f of 1. What is f of 2? 2 into f of 1. What is f of n minus 1? N minus 1 into f of 1. That is equal to given f of 1 is equal to 2, take 2 as common, we get 1 plus 2 plus 3 plus and so on n minus 1. That is equal to 2 into, now this is sigma n minus 1, that is n minus 1 into n by 2. Right, 2 gets cancelled. Given that g of n is equal to 20, that is equal to 4 into 5, that can be written as 4 into 5. N into n minus 1 is equal to 5 into 4, that implies n is equal to 5. Right, therefore the value of n, that is n is equal to 5. Now let us see another one. Right, this is the question based on the domain of the function. F of x is equal to sin inverse of mod x plus 5 by x square plus 1. The domain of the function is of the form minus infinity comma minus a union a comma infinity. Then we have to find the value of small a. Right. Okay. What is the domain of sin inverse? the domain of sine inverse, the domain of sine inverse, the domain of sine inverse is closed interval minus 1 comma 1. The domain of sine inverse is closed interval minus 1 comma 1. That implies the domain of f minus 1 less than or equal to mod x plus 5 divided by x square plus 1 less than or equal to 1. But this value is always positive for any value of x. So neglect this inequality. Simply mod x plus 5 divided by x square can be written as mod x square plus 1 less than or equal to 1. Right? Now that implies mod x plus 5 less than or equal to mod x square plus 1. That implies mod x square minus mod x minus 4 greater than or equal to 0. Right? Now, what are the factors of this quadratic expression? Okay, for the finding the value of mod x, minus b plus or minus square root of b square minus 4ac divided by 2a minus b 1 plus or minus root of b square minus 4ac divided by 2a. That is equal to 1 plus or minus root 17 divided by 2. Here this is mod x, 1 minus root 17 by 2 is a negative, but mod x is always positive, so that mod x is possible. Mod x is equal to only 1 plus root 17 divided by 2. Mod x is equal to 1 plus root 17 by 2. Right? That implies mod x minus 1 plus root 17 divided by 2 is greater than or equal to 0. Now mod x greater than or equal to, that implies mod x greater than or equal to 1 plus root 17 divided by 2. Now mod x, this is of the form mod x greater than or equal to a. Mod x greater than or equal to a, that implies x belong to minus infinity comma closed interval minus a union closed interval a comma infinity. So that the value of a is 1 plus root 17 by 2. The value of a is 1 plus root 17 by 2. Right, now let us see. Right, this is a relation defined by set of all ordered pairs x square plus 3y square less than or equal to x less than or equal to 8, x square plus 3y square less than or equal to 8 is a relation on the set of integers z. So here x comma y belong to z, then the domain of R inverse. The domain of R inverse. The domain of R inverse is equal to, the domain of R inverse is equal to the range of R. The domain of R inverse is equal to the range of capital R. Okay, now we have to find the range of R. How to find the range of the given relation? Right. Now x square plus 3y square less than or equal to 8, x square divided by 8 plus y square divided by 8 by 3 less than or equal to 1. Now this equation represents an ellipse. This equation represents an ellipse. Right. The values of a, this is a square. A square is equal to 8. A is equal to plus or minus 2 root 2. This is 2 root 2 comma 0. This is minus 2 root 2 comma 0. Now this is b square. B square is equal to 8 by 3. B square is equal to 8 by 3. That implies b is equal to 2 root 2 divided by root 3. So that this is 0 comma 2 root 2 divided by root 3. This is 0 comma minus 2 root 2 divided by root 3. Right. For finding the range of relation, range means see what are the values of y. What are the values of y? See the y-axis. See the y-axis. What are the values of y? So here x comma y belong to z. Observe that the value of b 2 root 2 by root 3. This is less than 2. This is less than 2. So the b value lies between minus 2 less than b less than 2. Minus 2 less than b less than 2, or minus 2 less than y less than 2. Minus 2 less than y less than 2. What are the integers lie between minus 2 and 2? What are the integers lie between minus 2 and 2? That implies y is equal to minus 1 comma 0 comma 1. Therefore, the range of R, the domain of R inverse is set containing minus 1 comma 0 comma 1. That is the domain of R inverse. Right. Now let us see next one. Right. Let a minus 2b plus c is equal to 1 given f of x is a determinant. Right, see, observe the determinant. Here 2, 3, 4 are in AP. Here 1, 2, 3 are in AP. Right? Okay. Now, for the simplifying the given determinant, R1 is replaced by R1 is replaced by R1 plus R3, R1 plus R3 minus 2R2. Okay, replace R1 by R1 plus R3 minus 2R2. Right? Now, f of x can be changed to R1 plus R3, x plus a plus x plus c minus 2R2 minus 2x minus 2b. That is a plus c minus 2b here. A plus c minus 2b here. Now, this is x plus 2 plus x plus 4. 2x plus 6 minus 2x plus 6. This element will be 0 and this element will be 0. The remaining elements are same. That is x plus b, x plus b, x plus 3, x plus 2. This is x plus c, x plus 4 and x plus 3. That is equal to determinant a plus c minus 2b. A plus c minus 2b is equal to 1, 1, 0, 0. X plus b, x plus b, x plus 3, x plus 2, x plus c, x plus 4, x plus 3. Now expanding the determinant along first row. Expanding the determinant along first row. That is equal to x plus 3 whole square, x plus 3 whole square minus x plus 2 into x plus 4. That is equal to x square plus 9 plus 6x minus x square minus 6x minus 6x minus 8. That is equal to, that will be 1. f of x is equal to 1, so that f of 51, f of minus 50 also 1, f of, okay, so that f of x equal to 1, it is a constant function, so that f of 50 is also equal to 1. F of 50 is also equal to 1. Right. Now let us see set A, that is mod x less than 2. Mod x less than 2, it means that is open interval minus 2 comma 2. Mod x less than 2, it means x lie between minus 2 and 2. Set B, modulus of x minus 2 greater than or equal to 3. X minus 2 less than or equal to minus 3. X minus 2 greater than or equal to 3. That implies x less than or equal to minus 1. X greater than or equal to 5. Therefore, set B is equal to minus infinity comma minus 1 union closed interval 5 comma infinity. These are the two sets given, A and B. Now verifying the options. Okay, right. Which option is true? Which option is true? Right. First option, what is A minus B? What is A minus B? That is the first option, A minus B. The elements present in A but not present in B. The elements present in A, not present in B is open interval minus 1 comma, open interval minus 1 comma 2. But here given closed interval minus 1. Now see the second one. What is A union B? A union B. Right. A is equal to minus infinity comma minus 1 union 5. This is B and this is A. A union B, that is equal to minus infinity comma 2 minus infinity comma open interval 2 union closed interval 5 comma infinity. This also can be expressed as R minus closed interval 2 comma open interval 5. So now B is not the answer. Now what is A intersection B? What is A intersection B? The intersection part of A and B is closed interval minus 2 comma closed interval minus 2 comma closed interval minus 1. Closed interval minus 2 comma closed interval minus 1. So this is not the answer. Now B minus A. B minus A. The elements present in B, not in A. Okay, open interval minus infinity comma open interval minus infinity comma minus 2 open interval minus infinity comma minus 2. Right. Union closed interval union closed interval 5 comma infinity. Okay, this can be written in another form, R minus closed interval minus 2 comma open interval 5. R minus closed interval minus 2. Okay, minus 2, this is open interval minus 2, this is closed interval minus 2. So here minus infinity comma closed interval minus 2, so that this is open interval R minus open interval minus 2 comma 5. So that the answer is option D, that is B minus A is equal to R minus open interval minus 2 comma 5. Right, now let us see the number of distinct solutions of the equation. Right, now write logarithms on one side, log mod sin x base 1 by 2 log mod sin x base 1 by 2 plus log mod cos x base 1 by 2 log mod cos x base 1 by 2 is equal to 2. That implies log a plus log b, log ab, logarithm of modulus of sin x into cos x base 1 by 2 is equal to 2. That implies modulus of sin x into cos x is equal to 1 by 2 whole square, that is equal to 1 by 4. That implies mod sin 2x is equal to 1 by 2 sin 2x equal to plus or minus 1 by 2. Right? Sin 2x equal to plus or minus 1 by 2. Here x belong to closed interval 0 comma 2 pi. 2x belong to closed interval 0 comma 4 pi. Therefore, sin 2x equal to plus or minus 1 by 2. So, there are 4 solutions in the interval 0 comma 2 pi and 4 more solutions in closed interval 2 pi comma 4 pi. Therefore, the total number of solutions, the total number of solutions that is equal to 8. The total number of solutions is 8. Right. Let f mapping from open interval 1 comma 3 to R, f mapping from open interval 1 comma 3 to capital R defined by f of x is equal to x into box x divided by 1 plus x square. This is very logical question. Here box denotes the greatest integer less than or equal to x. Now we have to find the range of f. We have to find the range of f. First write the function f in piecewise. Okay, if x lie between 1 and 2. If x lie between 1 and 2, box x is equal to 1, f of x is equal to x by 1 plus x square. If x lie between 2 and 3, x lie between 2 and 3, f of x is equal to 2x by 1 plus x square. Right? So, by observing f of x, clearly f of x is a decreasing function. Clearly f of x is a decreasing function. F of x is a decreasing function because numerator is always less than denominator. Numerator is always less than denominator, so that this is a decreasing function in both the cases. Therefore, the range of f, the range of f is equal to, f of 2 comma f of 1 union f of 3 comma f of 2. Right? Here f is a decreasing function, so that its range is f of 2 comma f of 1 and f of 3 comma f of 2. What is f of 2? Right, f of 2 is 2 by 5. What is f of 1? F of 1 is 1 by 2. Union, what is f of 3? F of 3 is 6 by 10, that is 3 by 5. What is f of 2? That is 4 by 5. That is 4 by 5. Right? 2 by 5, comma 1 by 2. Union, this is 3 by 5, comma 4 by 5. The answer is option 1. Right, now let us see. Right, f of x is equal to x into cos inverse of minus sin of mod x, x belong to closed interval minus pi by 2 comma pi by 2. Then which of the following is true? Right? Okay, here f of x can be written piecewise x into cos inverse of, okay, sin mod x is equal to minus x, so minus into minus plus x into cos inverse of sin x if x less than 0. If x less than 0. Now, if x greater than or equal to 0, x greater than or equal to 0, x into cos inverse of minus sin x. X into cos inverse of minus sin x. Now, what is cos inverse of sin x? What is cos inverse of sin x? That is cos inverse x. Cos inverse x, that is equal to pi by 2 minus sin inverse x, pi by 2 minus sin inverse x, that is equal to pi by 2 minus x. Now, what is cos inverse minus sin x? What is cos inverse of minus sin x? Cos inverse of minus x is equal to pi minus cos inverse x. Cos inverse of minus x equal to pi minus cos inverse of sin x. What is cos inverse of sin x? Cos inverse of sin x is pi by 2 minus x, that is equal to pi by 2 plus x, that is equal to pi by 2 plus x. Now f of x, that is equal to x into cos inverse of sin x, that is pi by 2 into x minus x square if x less than 0. Now x greater than or equal to 0, pi x by 2 plus x square. Right, now put x is equal to 0, this is 0 and this is 0, so that f of x is continuous at x equal to 0. Now f dash of x, that is equal to pi by 2 minus 2x, this is pi by 2 plus 2x, this is when x less than 0, this is x greater than or equal to 0. Right, so left hand derivative is pi by 2, that is equal to right hand derivative, so that f is differentiable at x equal to 0. F is differentiable at x equal to 0. Now take second derivative, f double dash of x, that is equal to minus 2 when x less than 0. This is 2 when x greater than or equal to 0. Right, therefore second derivative is less than 0 when x less than 0. Second derivative is greater than 0 when x greater than 0. So that f dash is decreasing in minus pi by 2 comma 0 and increasing in 0 comma pi by 2. Right, now let us see. Okay, the inverse function of f of x is, right, f of x is of the form e power x minus e power minus x divided by e power x plus e power minus x. This is the definition of tan hx. This is familiar to all. Okay, so that what is the inverse of tan hx? What is the inverse of tan hx or f inverse of x? Inverse of this one is 1 by 2 logarithm of 1 plus x divided by 1 minus x to the base e. Inverse of this function is this. Now here given that f of x, this can be written as 64 whole power x minus 64 whole power minus x divided by 64 whole power x, 64 whole power minus x. Now, what is the inverse of this function? Right, from the above, f inverse of x, that is equal to 1 by 2 logarithm of 1 plus x divided by 1 minus x to the base 64. But in options, this is not present in the options. So we can write logarithm property 1 by 2 logarithm of 1 plus x by 1 minus x to the base e into log e base 64. Log e base 64. This is also not present in options. So now 64 can be written as 8 square. 8 square, that is equal to 1 by 4 into log e base 8. 1 by 4 into log e base 8 into logarithm of 1 plus x by 1 minus x to the base e. Right. So this is the f inverse of x, that is option C, 1 by 4 into log e base 8 into logarithm of 1 plus x by 1 minus x. Right, these are the questions asked in previous JEE mains examinations. Right, okay, thank you.